I have a quick puzzle for you all. Watch closely because again, there's a question for you at the end, right? So let me start with the video. That was your scene 1. Now I'm going to start with scene 2. Now scene 3. So take a second, be ready. Are you guys ready? Okay, let me start. Right? And now finally the question. So we have a similar question, right? Did you guys get to see how many objects were there in each scenario? Or the different or the same? Or the different or the same? Let me show it again. Right now you guys can actually count it, just since you guys know the end question. So let me start this again. So did all the scene have the same number of objects? Answer is yes. And are the number of objects the same in each case? Yes. Did the order in which they appear matter? No. End of it, all had 10 objects. You guys agree? There were 10 objects. So this is your associative property. So that was a kind of a hint towards what we are going towards. So let's have a concrete example over here. So the basic idea over here is that how numbers are grouped using brackets in addition or multiplication problem does not is important. Again, we are dealing with addition and multiplication. Does not affect the sum or the product. Imagine you are counting your collection of marbles. Okay. If you first count a group of 3 red, like over here, and 1 blue, like over here again, and then 5 green marbles to that total, you will get the same result as if, right? So this leads to 9 marbles. Or if you happen to find your first you happen to count your first blue marbles. In this case, it's blue marble actually. And then 5 green marbles together, right? So 1 plus 5, that is 6. And then add the 3 red marbles to that. So that's how you count, is it not? So if I have to count, I will go with, okay, 3 plus 1. Again, you're finding it in groups. It's not going to be that it will be 3 and then 1 and then 5 put together. It's not going to be visible in that way. You're going to find red first and then one single blue and then the green ones. Here you're finding blue first and then the green and then the red. But will the result change? It's a simple question and the answer is no. And that's what is your associative property is about. You can first add A plus B and then C, or you can add B plus C and then A. That is, you can add 2 plus 3 and then 4, or you can add 3 plus 4 and then 2. So these two examples. So let me take one more example so that I can explain step by step. See, we have our aim is to simplify 4 plus 10 plus 2. Okay. I have two options. Option 1, I can go with 4 plus 10 first. That will give me 14. And then 14 plus 2, which is equal to 16. Then we have option 2 herein. We can do 10 plus 2 first. That will give me 12. And then 12 plus, or in this case, 2 plus, oh my bad, I'm looking at the wrong question. 4 plus 12. 4 plus 12, which will give me 16. Did it give the same answer? Can you guys see that? It gave us the same answer. But the intermediate step, right? This is the intermediate step. Those answers are different. They need not be same. So these are intermediate answer. Intermediate means in between. Right? If you're cooking something, the intermediate is, say, half cooked material. Right? If you are roasting something and you end of it, you have to put back to something else. What do? You roast it half and put to the rest of it, or mix the rest of it to the first item. Provided the first item needs a lot of roasting, you do that. So these are intermediate steps. So intermediate steps can be different, but the final answer is same. Same holds good even with the presence of negative sign. That is, a plus of minus b plus c is same as a plus of minus b plus c. That is, if you have 10 minus 3 plus 5, it's same as 10 plus minus 3 plus 5. That is, 10 minus 3 is being subtracted per se over here, or added, or minus 3 is added to plus 5. And then the third number, if you go in any sequence, you'll end up with the same result. Again, example. Aim is to simplify, say, let me take some other number, 4 minus 2, 6 minus 2 plus 4. So I can go with two ways. Option 1, first I can do 6 minus 2, which is 4. And then 4 plus 4, the result of 6 minus 2, that is 4. So this will give me 8. Or I can do the following. Option 2, I can do minus 2 plus 4, that is 4 minus 2, which is equal to 2. And then we have 6 plus 2, right, which is equal to 8. Again, as you can see, the intermediate steps are different while the final answer is the same. You guys agree? So this is to do with associative. The word associate means what? Associate means to be related to. So what you relate first, what numbers you relate first, and simplify, it won't matter, provided you go to the final step. So till the final step, you can get different answers, but the final answer will always be the same. And this holds true even for multiplication. 2 into 3 into 4 will give me the same answer as 2 into 3 into 4. That is, 2 into 3 being multiplied first, or 3 into 4 being multiplied first, will not affect the answer. Again, let me take up an example. 4 into 3 into 2. Again, the aim is to simplify. So I can go with 4 into 3, right? I can go with option 1. 4 into 3 first. That will give me 12. And then let me use the same color. And 12 into 2, which will give me 24. Or I have option 2, which is 3 into 2, which is equal to 6. And then we have 4 into 6, that is 24. And so we end up with the same answer, doesn't matter the order of operation. Okay, does it make sense? Yeah. So this is to do with associative law. So associative is to be related to. So what you relate first and then end up with another number, the order in which you relate will not matter, is the entire theorem, entire idea.